first of all, let's talk about how an angle is created. In order to create an angle, what you need is two non-collinear rays, right? So imagine here's a ray, and remember a ray has an end point, but it goes on infinitely in the other end. So that's one ray. Another non-collinear ray, so not lying on top of each other, right, would be this one. And if they're joined at the end point, then the point where they join becomes the vertex, as you can see here. Now, the starting position, we call it the initial side. So imagine, right, if this is your initial ray, and then imagine you clone that ray so that it's now, the second one is lying right on top of it. And then you start rotating it, right? And you stop somewhere. Well, the position where you started, that will be the initial side. And then that second ray that you rotated up, that would be the terminal side, right, where it ends. As you can see here, initial side, terminal side. Now, an angle can be anywhere in space. But if you take your angle and you anchor it down on the x and y coordinate plane so that the vertex is at the origin and the initial side lies on top of the x-axis, we call that an angle in standard position. All right? Okay. Now, let's talk about how you measure an angle. When you have that initial side, and we said you can rotate that second ray, right? We never said whether you rotate upwards or downwards. So if you rotate this way counterclockwise, that will become a positive angle. It would have a positive angle measure. But from that initial side, if you rotate in the clockwise position, that will have a negative position, a negative angle measure, okay? So that's where you have angles of like positive 30 degrees or negative 30 degrees. Okay? All right. Speaking of degrees, how do you measure angles? Just like, for example, when you're talking about temperature, there are two different degrees, right? Celsius and Fahrenheit. With angles too, you have two different units. One unit, which is most commonly known, is the degree. All right, so 1 degree is equivalent to 1/360th of a full rotation. What does that mean? So how many degrees have you made if you go all the way around a circle? 360, right? Now, imagine you buy yourself a pizza, okay, and it's like some mathematician made this pizza, right? So it's like perfectly round, yes? Okay, now imagine instead of the usual 8 slices, you cut up your pizza into 360 slices. One pizza, 360 slices. Imagine for a minute what one slice will look like. It's going to be like a tiny sliver, right? Well, that angle is 1 degree, right? There are 360 of those in a circle. So it's tiny, okay? There are 30 of them just here, okay? All right, so you can see here, as you go around the circle, you have your 0 degrees, 90, right, 150, 180, all the way around to 360. Okay. The second unit of measure for angles are radians, abbreviated as rad. Okay. What is our radian? Okay. Let's take a look at this circle here, and I'm going to make it a little bit bigger. Suppose this was a circular track field. You know how track fields look? They're kind of like elongated like this, like an oblong. Imagine you had a perfectly circular track field, right? And so imagine the radius of the field was 10 meters. Okay? Now, suppose you're here, and suppose your coach makes you walk this distance around the track, right? So you start here, and he's got a pedometer on you, so it's tracking your steps. And you start walking, 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 and then the minute it hits 10 meters, you stop. Okay? So now you've walked a distance of 10 meters. That distance, that portion of the circle that you walk is called S. We call it the arc length. Can you pull your mask up a little bit more so it covers your whole nose? Thank you. Okay. 10 meters, right? So now, how much was the radius? 10 meters. How much did we walk around the circle? 10 meters. What's the ratio but S to R, the distance you walked to the radius? What's that ratio? 10 meters to 10 meters, 1, right? Okay. When you're here, you see how you've made an angle with your initial position? Because that angle was created when you walked the same distance as the radius, and there's a 1-to-1 ratio, that angle is 1 radian. That's how we measure radian. Okay? So let me do this, and then I'll take a question. Now suppose you continue walking here. And now you've walked 20 meters. Now the angle you've made is this much. What's your ratio of S to R? 20 to 10, it's 2, right? So that is an angle of 2 radian. Okay? Did that answer your question? I thought it might. Okay, now, suppose you walk a little bit more. Here. Okay? So now you've walked a total of 30 meters, and that's your angle now. So what's your ratio, S to R? 3. So how many radian is that angle? 3 radian. So you see how big 3 radian is, right? Now, suppose you walk a little bit more. You get to here, and suppose your coach just stops you, and you looked at and you've walked 31.4 meters. What's that ratio now? 31.4 to 10. How much is that? 3.14. Have you seen that before? That's pi. That's pi radian, right? 3.14. So that angle is 3.14 radian. How many degrees is it? That whole angle from here to here. How many degrees? It's 180 degrees. And we now know that it's 3.14 radian. Well, the Greeks came up with a letter for that, a symbol for that, because it happens so often, pi. So that's what pi is. Pi is the angle you make when the distance you walk around the circle to the radius has a ratio of 3.14. It turns out, no matter what circle you get, okay, no matter what circle, whether it's a tiny circle like this, or whether it's a huge circle like that, when you walk this distance, okay, the ratio between that to the radius is 3.14. And the ratio between that to that radius is also 3.14. Right? That's where pi comes from. So, if it's pi until there, okay, how much total is it for the full circle? Yeah, 2 pi, right? So, if walking half the circle gave us an angle of 1 pi, then walking the full circle would give us an angle of 2 pi radian. Okay? So that's where it comes from. Okay? So going with our distance, so suppose you now walk around the whole thing, and you've walked, now when you look at your speedometer or your pedometer, you've walked 62.8. meters. What's the ratio? 62.8 to 10? 6.28, that's 2 pi. Okay? So, where did that come from though? 62.8, that was S, right? Over R. But S is the portion of the circle. When we do the whole circle, we no longer call it S, because S was only a portion. The whole distance around it, we call it C, right? So that's C over R. And we said that ratio was 2 pi, right? So if you solve that for C, what do you get? 2 pi r. That's where the circumference comes from. Okay? Yep. Yep. That's where it comes from. It's the Greeks. Those Greeks, right?
Yeah. That's really cool.
It is one of the coolest things. It's one of the coolest things because it's such a simple thing, but it's also such a right? Mind-blowing, huh? Right. Yeah. Yeah. And I don't ever, and another teacher wouldn't have gone through all this, but I like to walk you guys through it because I think it's cool where radian comes from. It's not some obscure thing. Okay, I'm going to call this a radian. It's not that. It actually comes from somewhere. All right? It's not an arbitrary measure. Okay, so that's where all this is. Okay, that's what all this says. So then we come to this realization that going 360 degrees around a circle is the same as 2 pi. And going 180 is the same as pi. And that, right, you're going to carry with you throughout this chapter. Right? 180 degrees and pi are the same thing. So now, when you have to convert radian to degrees, the book tells you to use these formulas, right? And I always put these in here for one reason, so that when I show them to you, I can tell you, cross those out, because I don't want you to ever memorize anything in here. The reason why I went through all that with the pi is so you understand what it is, so you don't have to memorize anything. That's not what Precalc Honors is about, okay? Students who who pass their math classes by memorizing, it comes a point in their life where it no longer works, right? So you got to understand and reason through things. Okay, so now I have to convert this into radian. Well, whenever I'm converting anything, I do times fraction bar. Now, what's the relationship between radian and degree? Well, 180 degrees is the same as pi. So, here I have degrees in the numerator. Here, degrees must go in the denominator. And pi goes on top. This way, degrees cancel. So, I can divide these by 5s and so on. This ends up being 3 over 4 pi, which we can write as 3 pi over 4. Okay? Now, next we have negative 30 degrees, same thing, times fraction bar. Degrees are on top, so they go on the bottom here. Pi goes on top.
Does pi always go on top?
Well, in here, because it's 180 and pi. One has to go on top, one has to go on the bottom. Right? So let's do this one, then when we move to the next one, you'll see.
Okay.
So here it's negative, and then when these reduce, you get pi over 6. So that's negative pi over 6. Okay, here we're going to convert to degree times fraction bar. My conversion factor is 180 and pi are the same. Here, pi is on top, so it's got to go to the bottom in my fraction. 180 on top, so pi's cancel. So the thing is, if an angle is in radian, it'll be in terms of pi, usually. And here, 2 pi over 3, 2/3 times 180, that'll be 120 degrees. Okay. Times fraction bar, pi goes on the bottom, 180 on top, and this will be negative 135 degrees. So you should be able to work through that without a calculator. Okay? Questions so far? All right. So what I said earlier was, when an angle is in, I said this exact same sentence. When an angle is in radian, it is expressed in pi, and then I said the word usually. And that was on purpose. Because most of the time, we'll say, okay, I have an angle of pi, right? And that's in radian. But you should also know the decimal equivalent of that. And the decimal equivalent of pi is 3.14. Remember, you know this. So, if this is 3.14 here, that's 1 pi, right? Well, half a pi would be here, right? That's half the distance. So that would be pi over 2. And if this is 3.14, then this would be half of that, which is 1.57. Okay? Now, so half a pi, 1 pi, another half a pi. So when I'm down here, this is 1.5 pi. What's another word for 1.5? 3 over 2. Okay? So it's 3 times, 3.14 over 2. That's 4.71. Okay. You don't have to memorize all those. But you should know that it's 0, 3.14. So if you have an angle of 2 pi, you should know that it falls somewhere here. Okay, if I have an angle of 5 pi, okay, so like if this is 3.14, this is 6.28 because it's 2 pi, 2 times 3.14. So if I have an angle of 5 pi, I should know that it falls somewhere over here, okay? You can see better here, okay? Yeah. All right. Okay, let's go on to coterminal angles. So coterminal angles are angles that terminate or end at the same place. All right? Okay, so take a look here. Suppose, this is an angle of 50 degrees. Okay? So if I wanted to draw an angle of 50 degrees, I start here and I go up, and that's 50 degrees. Okay? Now, suppose I wanted to draw an angle of 410 degrees. Yeah.
What does it say? Is that like X, or so it's like what is the
symbol?
Yeah, the symbol. Yeah.
So this is the Greek letter alpha. That's like a little fish. And this is the Greek letter beta. Alpha and beta used to be like the
cells.
They used to be like the symbols for random angles, and then somehow they got changed to like A, B, and C and X, Y. Okay, yeah, they're just Greek letters, alpha and beta. This is the same as this is alpha. That's how we write it. Okay, don't worry too much about that. Just know theta. Theta, that you should know. Okay, so suppose I wanted to draw an angle of 410. So I start here, and I go around 90 degrees, 180 degrees. Okay, this is 270 and then 360. How much more should I go to make it 410? 50 more, and look at where I go. I end up at the same place as my 50-degree angle, right? So there are different measures, very different measures, but in, it looks like they start and end at the same place. So we call those coterminal angles. All right? Okay. So so what's another way to do the same thing? If I started here, how much would I have to go around to get back to the same place? 360. And does it matter if I go to the left or if I go, clockwise or counterclockwise? No, both ways I would end at the same place. So then how do we find coterminal angles? We either add or subtract 360 degrees. And if my angle is given in radian, then instead of 360 degrees, how many radian would I add or subtract? 2 pi. Okay? All right. So here it says, first, identify all angles which are coterminal with the given angle. Then find one positive and one negative. Okay. So to find all coterminal angles, I start with my angle 80. And then to that, I'm going to add 360, right? Okay? All right. Now, what if so now don't write this yet, but what if I added 2 360s? Would that be the same thing? No?
Oh, yeah.
Yeah, right? Because 360 and then another 360. What if I did 4 360s? Same thing. So I could add an n number of 360s. Can I also subtract that many 360s?
Yeah.
I can. So the way I can write that is, it's 80 plus or minus 360n. Okay? So that's an expression for all of them. All right, now, let's now find one positive and one negative coterminal angle. For the positive one, I do 80 plus 360. And how much is that? 440. Okay? For the negative one, 80 minus 360, and that's negative 280. Okay, so one thing you have to be careful about is a negative coterminal angle actually has to have a negative sign in front of it. It doesn't mean, just because you subtracted, it doesn't mean that it's a negative coterminal angle. More about that soon. So here, negative pi over 4. So all coterminal angles, what would we do?
Add or subtract.
2 pi n. Good. So negative pi over 4 plus or minus 2 pi n. Whether it's 2 pi n or 2n pi, it doesn't matter. It's just preference. Okay, in real life, it doesn't really matter. The book has it one way or another. I can't remember. Okay, so for the positive one, we're going to do negative pi over 4 plus 2 pi. Yep.
What if it was one but realizing it's just whole numbers? Is that what
Yeah,
okay.
and it's just whole numbers. Yeah, good. Okay, so negative pi over 4 plus 2 pi. Okay, so let me show you my very quick way of adding a whole number to a fraction, right? So it's going to equal a fraction, and the denominator is going to be the same as the one you have because there's only one denominator to work with. Now, here is what I do. This is my preferred way. I do a loop. Denominator times whole number is what? 8 pi plus, then add plus negative pi. 8 pi plus negative pi. 7 pi. So that's 7 pi over 4. Okay? To subtract, we're going to do the same thing. Yes, 7 pi over 4. Negative pi over 4 minus 2 pi. Okay? Same denominator. And then same thing. 4 times negative 2 pi this time is how much? Negative 8 pi. Plus another negative pi. negative 9 pi over 4. So that's how I do those. Okay? So one other thing I want to hit home is what I was saying earlier. So suppose you have an angle of, I don't know, 660 degrees, okay? And you want to find a positive and a negative coterminal angle, right? So, okay, so for the negative one, you subtract 360, what do you get? 300. Okay, so you subtract the 360, but you still get a positive angle. That's still not a negative coterminal angle. So you have to do it again. 300 minus 360, how much is that? Negative 60. Now that is your negative coterminal angle. That's it. That's it. Like that. When it says find one negative coterminal angle, that's what it is. It's not the 300, it's this one. So now, for the positive coterminal angle, okay, you have some choices. If it's something like this, all the ones that you hit on your way, which are positive, can still be considered positive coterminal angles. So this one can be used as a positive coterminal angle, even though you're subtracting. Or if you didn't, so if you see it first, right, and you're like, oh, look at that, like I'm going to get a positive one on my way to the negative one, I'll just start with this, and here's my positive. Or if you didn't catch it, and so first, you mechanically just added 360, and you got 960, 1020, then that works for your positive coterminal angle as well, right? So there could be an infinite number of possibilities. Okay, so either one of those can be the positive.
Would you want us to write both or
just one is sufficient, and usually like on my, I usually know that, both of them will work.
And you can also do this with the pi?
Yep, same thing with pi. You can keep subtracting 2 pi until you get a negative one, or keep adding 2 pi until you get a positive one. Okay? All right. So for homework for tomorrow, so this is a 2-day lesson, and I see you again on, tomorrow. I would like for you to do just the first 2, because that's how much we've done, just 11 and 17. Tomorrow we're going to continue the lesson, and you can do the rest. All right?